So to continue where we left off with section 1.7 from before, we've covered midpoint in the coordinate plane. Now we're covering what we call the distance formula in that same coordinate plane. So last time we're trying to find the midpoint of a segment, and again, that could be either from a number line or from an XY coordinate plane. But now we're going to be looking for the distance or length along that segment from point A to point B. You could also think about it as going the opposite direction. Doesn't really matter as long as it's that same length. And we're going to find that distance by using this big, kind of looks scary at first, but we'll see how it's going to be used in a second, what we call that distance formula. And we described down below, you guys are free to copy that part down, that what we're essentially doing is really finding the hypotenuse or longest side of a right triangle. That's because if we're familiar with what we call the Pythagorean theorem, a squared plus b squared equals c squared, a and b being the two legs of a right triangle and c being its hypotenuse, we're going to be basically reordering that formula around in a way that solves for c, and that way we're just going to find, again, the length that goes from point A to point B, which is what we need for our coordinate plane. So just putting that into practice, again, we're essentially just using that formula from up above and substituting in values from our question. We're trying to find the distance between u and v in the coordinate plane given by those two pairs of coordinates. Kind of like what we did with midpoint. I think it's good for every kind of coordinate plane question to just label your coordinates because we will need to use all of those in the distance formula. We're also asked to give our answer in two different ways, as a simplified radical and also as a decimal rounded to nearest tenth. So when we answer this, we'll talk about that again after we've got our formula down. Let me get this back. But yeah, the nice thing about the distance formula is essentially when I see this in the formula, x2 minus x1 squared, all we're really looking for is essentially just the length of what would have been the side of that triangle. So it doesn't even matter what I call x1. Like this could be my first x, that could be my second x. It doesn't matter for the coordinates in their order. All we're really doing is trying to put that together in like that horizontal distance. And the same thing with the y's that I see in the formula. y2 minus y1 could actually be in a different order because all we're using that to represent is, again, just the length going in a vertical direction. So as long as we have our horizontal and vertical distance covered, there's actually a lot of things we can kind of put in a different order in this formula and still get it correct. So I chose the first coordinates x1, y1, and the second one is x2, y2, but this is going to work either way, like I said, if you were to flip that around. But sticking with that formula, again, distance is going to be a big square root, and then inside our first quantity squared is going to be the difference between the two x's. Again, I chose them in the order 4 and then -7 is x2 minus x1. But again, if I was to flip the order, it's still going to work because we're squaring this. It's not essentially not going to matter what the sign is. Anything squared inside those parentheses is going to come out as a positive. And then we're also going to have the second part of the formula, again, kind of representing our vertical distance if the first grouping symbols were our horizontal distance. And that should be -3 for y2 and then 5 for y1. You do want to make sure that you're subtracting in between. I see a lot of people make mistakes there. I do also want to make sure we are adding those two quantities together. But as long as we got the signs right and as long as we're good with our integers, our next step, and really all of our steps for our formula, is kind of just simplifying this stuff down. So like I said, we want to be careful about integers. Subtracting a negative is like adding a positive. So 4 minus -7 is going to give us 11, still squaring that. -3 minus 5 is going to give us -8, and we're squaring that as well. And notice if I was to reverse the coordinates in my formula, I would have a -11 and a +8. But since I'm squaring both quantities, they're both going to come out as a positive for this next step either way. So again, it doesn't really matter about the order so much. The big idea, though, is that you want to keep x's together and y's together. So x's from each coordinate, y's from each coordinate. If I was to, for example, like do -7 minus 5 in the same coordinate pair, that would give us a wrong answer. So going back to our formula, 121 is 11 squared, 64 is 8 squared, and then if I was using this square root of 185, what it means to simplify a radical is I want to make sure I'm removing any perfect squares that appear in that radical. And since if I was to factor this down, kind of unique factors here for a square root of 185, only way to multiply to get 185 is to do 5 times 37. Both of those are prime numbers, so they don't have any factors that I can break this down further. So this is actually as simple as this radical is going to get. Square root of 185 is going to be my simplified radical answer. And then if I was to use my calculator and just punch that in, find it to the nearest tenth they're asking us to round to, that's going to come out to about 13.6. And with the question beneath it, again, you're using the exact same formula, just different coordinates this time. Again, also whenever I'm trying to find something like SR, we know that we're trying to find length because we don't have any kind of segment marking. We don't have any ray marking, line marking over it. All we have is SR, which is always going to mean the length of that segment. So if I'm using this same formula, again, good one to try by yourself, let's check it out and see how this one went. Again, but just by sticking with my two pieces, I just labeled the first two, like my x1 and my y1. and then my my x2 rather, and then my y1 and my y2. As long as I stuck with those same kind of coordinates, I just kind of picked the same order as the previous question. So again, just want to make sure your x's are together and your y's are together. But in your work, if you got like a -5 and then a +15, since we're squaring both quantities, again, not going to matter too much about their signs. In this case, though, once I do get my radical, there is a way that I want to simplify that down. Square root of 125, or sorry, square root of 250 rather, has 25 as a perfect square factor. So if I was to remove that perfect square factor, since it simplifies to just 5 by itself, I want to remove that 5 from the square root. But since all I'm left with is 10, the other factor, if I was to multiply to get 250, 10 doesn't have any perfect square factors, so that part will stay inside my radical sign. So that's what it means to simplify a radical. Instead of writing square root of 250, if I want to write this in what we call simplified radical form, 25 is a perfect square. We factor that part outside, just like in our pre-assessment, if we remember from the start of the year. And then we also can answer that as a simplified radical. Again, don't really have to enter our simplified form, but punch that in on your calculator. That's also going to give you an answer to the nearest tenth, which is what they're looking for. Again, that's another thing, I guess, to watch out for that question that we didn't say on the last one is last one we made it clear that we're looking for a distance. Here, we're also looking for a distance. But yeah, we want to make sure we know what we're looking for with something like SR by itself. That's just the length of that segment S, from S to R. So this question essentially is the same as what we've already seen. Only difference now is that we kind of throw this into more of like a word problem or kind of situation that we have to conceptualize a little bit first. But essentially, if I'm just trying to find the distance from platform B to platform C, that's basic behind this kind of zip lining question. We just want to basically find the distance between these 2 points, just like we did on that last question. But I guess one of the additional steps that we didn't have to do before is we just want to figure out where those 2 points are located. We do want to make sure it's x values first and then y. A lot of people do reverse that, but if we're being careful about our order, that's -30 for an x coordinate for point B, -20 for my y coordinate, and similarly for C, it looks like we're at -15, remembering that we're counting by fives, and then it looks like 10 for a y coordinate. So now that we have those two, if I'm looking for the distance from B to C, it's essentially the exact same as the question that we just solved. So like we did before, I just kind of like to keep track of my coordinates and make sure I can just substitute that directly into my formula. I'm just going to pick B for my first coordinate and C for my second. And by using my distance formula, again, all I want to do is make sure the x's are together when I subtract. So -15 minus -30, but again, order could be different there if we'd like. We do want to add in between, and then we have our vertical distance represented by 10 minus -20. Again, those were our two y values that we were looking at. And the rest of this, again, a lot of the work on distance formula is just simplifying all this stuff down. -15 minus -30 is going to be like adding, so that's going to come out to a +15 that we're going to square. And then if I have 10 minus -20, again, subtracting another negative, that's going to come out to 30 that we have to square. So if I was taking another step, it looks like I have 225 and 900. You could even put all this into the calculator on that step, since there's no variables. And you could really put the original into the calculator, still going to find it. But yeah, if I'm still simplifying this down in steps, we do have a radical answer that we could use, although it's not simplified. This question, though, it's always good to look back and see what we're actually trying to answer, or what kind of form, rather. It looks like we're trying to answer that to nearest 10. So just by punching that last answer into our calculator, this is, I think, 33.5. 33.54, and then we round that down. Doesn't give us any units here, so I'm just going to say that's 33.5 in general, whatever kind of units that they started with. But again, as long as we're careful about keeping the x's together and the y's together, distance formula, just want to make sure you're able to simplify that all right.